Welcome to The Explainer. Today, we are cracking the code on a super powerful tool in trigonometry. It's a tool that lets you find the exact value for angles you might think are, impossible to solve without grabbing a calculator.
Here's our roadmap for this explainer. We're going to start with a fun little puzzle, introduce the formulas you need to solve it, then we'll put them to work, and finally see where this stuff actually shows up in the real world. Okay, let's dive into this.
All right, so we're starting with a challenge. It's a problem you just can't solve if all you know are your standard 30, 45, and 60-degree angles.
So here it is, our big question for the day. How in the world can we find the exact value of the tangent of 75 degrees? Now, it seems tricky, right? Because 75 degrees isn't one of those special angles we all had to memorize from the unit circle. But trust me, by the end of this, you'll see it's actually a pretty straightforward puzzle.
The solution? Well, it lies in two new formulas that act kind of like cheat codes for these non-standard angles. And since tangent is really just sine over cosine, these tangent formulas are actually derived directly from the sine and cosine sum formulas. It all boils down to one single elegant fraction.
So first up, we've got the tangent sum formula. This is your go-to when you can express your tricky angle as the sum of two angles you do know. And just notice the structure here. You've got a sum in the numerator and a difference down in the denominator.
And here's its twin, the difference formula. You use this one when you're subtracting angles. Now, it looks almost identical, right? But the signs are flipped. And keeping these signs straight, well, that's going to be the key to your success.
Now, this little phrase right here, this is an absolutely fantastic way to remember the signs. Just burn this into your brain. The numerator sign agrees, the denominator sign disagrees. So what does that mean? For a sum formula, the numerator has a plus sign. It agrees. For a difference formula, the numerator has a minus. The denominator is always the opposite. This little saying is the key to getting this right every single time.
And check this out. This table shows how beautifully the tangent formulas fit into the bigger family of sum and difference identities. For sine, the sign always matches. For cosine, it's always the opposite. And tangent, it's just this clever combination of both patterns. It's such a neat and consistent system when you see it all laid out.
Okay, enough theory. Let's actually put these formulas to work. We're going to solve our original problem, and then we'll tackle another really interesting case that reveals something super cool about how these formulas actually function.
So back to our 75-degree problem. The very first step is to find two friendly angles, the ones from the unit circle, that add up to 75. And yeah, the most obvious choice here is 45 degrees plus 30 degrees. We know the exact tangent values for both of those, so we're good to go.
Now we just have to apply the sum formula. Easy enough. We substitute tan of 45 degrees, which is just 1, and tan of 30 degrees, which is the square root of 3 over 3. Now the rest is just being careful with your algebra. We simplify that complex fraction, and then we rationalize the denominator, which is just a fancy way of saying we multiply the top and bottom by the conjugate to get that square root out of the denominator. And once we do that, bam, we get our clean final answer. 2 plus the square root of 3.
Okay, now for a really fascinating edge case. We all know that the tangent of 90 degrees is undefined, right? So, what happens if we use our brand new sum formula to calculate it? By adding 45 and 45. Is the math going to hold up? Let's find out. So we apply the formula just like we did before. Tan of 45 plus tan of 45 goes in the numerator, so that's just 1 plus 1. And 1 minus tan 45 times tan 45 goes in the denominator, which is 1 minus 1 times 1. And, oh, look what happens. We get 2 divided by 0. And that is exactly right. You can't divide by 0, it's undefined. The formula doesn't break. It perfectly confirms that vertical asymptote we see on the graph of the tangent function right at 90 degrees. I just love that. It's such a beautiful piece of mathematical consistency. Now, before we move on, let's talk about the single most common mistake people make when they're first learning this, just so you can be sure to avoid it.
It all comes down to the signs. It's always the signs. Just remember our little mnemonic. For a sum, the numerator agrees with a plus sign, and the denominator disagrees with a minus sign. Swapping them is the #1 error, but if you just remember that simple rule, you'll be all set.
So, the big question, why does any of this even matter outside of a math test? Well, you might be surprised where these seemingly abstract formulas pop up in the real world.
Literally, every single time an object rotates in a 3D video game, the engine is furiously crunching numbers using these sum formulas to figure out its new orientation.
The tangent function is especially important for defining the field of view for in-game cameras. So you see, these aren't just abstract equations. They are the fundamental tools that are building the digital worlds we interact with every single day.
And that kind of leaves us with a final thought, right? Mathematics is absolutely full of these elegant tools, just like this one, that are designed to turn really complex challenges into simple, manageable steps. I mean, our 75-degree problem seemed impossible at first, but with the right formula, it became pretty easy. So the question is, what will you unlock next?